Welcome to the channel with me, your host and star of the show, James Costello. I actually recorded this already, but I didn't have the mic turned on. There's going to be a little bit of a change to the way we do things around here. I'm sick of doing that kind of heavy formatted thing. So this is going to be more conversational from now on. We'll see. Maybe I'll hate that too. But anyway, let's dive in. So what we're looking at here today is the ESC. Let me get an overhead. Is the ESC3B04. What is this? This is a breakout board for the ESP32-C3 Super Mini. And what does it have? It's got 4 relays. Got a RS485 half duplex on it, and it also has four digital inputs and or analog inputs. First thing about this thing is how much I hate the orientation, and I'll show you in 1 second why that is the case. Banging around in the background here, don't mind me. So DIN rail mount. It snaps on just like this. Wow. But I don't know if you're familiar with DIN rails or how these things actually are used in a industrial setting or semi-industrial or the hobbyist setting. But what you don't want is your inputs and your outputs facing along the DIN rail, because that's where you put stuff. Like this. So if you've got a relay, what the hell do you do with these things? You put it on this side, this is where your power supply, comes in, or your RS485 or your inputs or whatever. Terrible design. Now, initially I was like, oh, maybe it was just put together wrong and I could take off the sides here, and spin the board around, and it would fit nicely and everything would be great. Not so. The board itself is not square, so I wasn't able to turn it and slide it back in because it didn't fit. So here we are, and it is what it is. There's no changing it now. Whoever makes this Tech Shop, who knows? I got it off AliExpress anyway. I think it was relatively cheap. I think it was like €15. It might have been a little bit less. And I thought it looked really cool, and it does look cool. It's actually, it feels good. It's a nice little board. But that's super annoying. So, what else about this thing? Another kind of thing that annoyed me was the analog and the digital input on it. So the schematic that they have for it shows that you're using an LM324 for a buffer amplifier. But then the LM324, just by the characteristics of the chip itself and the way that the guys powered it with 3.3 volts, means that the max output that you can get from it is theoretically 1.8. I measured it at 1.9, and you can see that on my website. I'll put a link in the description where I kind of go into a little bit more detail of how the board itself works. Yeah, which is a bit annoying because the onboard ADC works up to 3 volts, and then if you put 3.3 volts on it, it just becomes saturated, but it works up to 3.3. So you're putting in, when you put in 10 volts, you get out 1.8, which you're just, needlessly losing range there. And then that also goes for the digital inputs. So the digital inputs, from the spec sheet from the ESP32-C3, it says that the threshold for a high signal on the digital input is 2.4 something. Now this thing can only output 1.8 in theory, 1.9 in practice. So you're kind of landing in the gray area. Now, when I did test it, it ended up being, it ended up still working, but it might not always work because you're in the gray area. Yeah, so that's not great. Okay, let's move on to, but other than that, great board. Other than those things, it's a brilliant board. Now, I haven't obviously tested it in an industrial setting. I've just had it on my desk here and, messing around with it. So let's now go have a look at the library that I wrote for it. I'm just going to zoom in here a little bit on it. Zoom, zoom, zoom. Zoom, zoom, zoom. That looks good there. Let's switch to the left with an overhead. Yeah, so this is the library for it, and I actually put this up on the Arduino one, so you can just come in here and type ESC3B04, and here it is. This is the first iteration of it. I'm assuming that I'll do more in the future if there's any bugs or whatever, but now I've tested the code and it looks pretty good. So here it is on the Arduino library list. So you can install it there and you'll get these examples that I'm about to show you. So this is actually the simple PLC one. So let's give you a quick what to look for. This is what it will look like, and then we'll have simple PLC. I've got a couple of other ones, but this, gives you the general gist of, what I'm doing and what's actually going on here. Yeah, let's dive into it. So, initializing the library here, I'm calling it PLC. You can call it whatever you want. So then in the setup, we're initializing it. Then inside the initialization method here, it just sets the pins to be the right, if it's an input or if it's an output or if it needs to be an input with a pull-up resistor, all that kind of stuff. And it also sets the serial communications inside in it. Now, what I've done with this is I've prioritized the RS485 onboard chip here. So if you try to do like a normal serial print over USB, it won't work here. You have to use the onboard RS485. But you can just put in your own like serial begin, and that should work with the USB if you have the USB CDC enabled. Yeah, so for the onboard RS485, the default settings are 115200. This does go up to according to the datasheet for the onboard RS485 chip, this does go up to 330 400, but I just put the baud as 115200 because that's a fairly common one. And the end character is carriage return. I don't show it here, but the timeout is 3 seconds as well. So that just means if you receive a character and you don't receive the end character within 3 seconds, then it times out. What else do we have here? Right, so in the main loop we have the engine, and the engine handles the handles the button debounce, the analog averaging, and the serial communication. So the serial engine is inside in there, and it's just reading characters, looking for the end character. Also, if you go into some of the other examples, it will show you how to set a start character and change the end character and things like that. So the first one here, what we're doing is setting CH1. CH1 is this relay here, and we're setting that to be true if and only if the analog input is greater than 4.5 volts. So I don't actually have a really good way to do this, but you'll get the idea of what's going on. So what I'm going to do is this guy here, this kind of exposed pin on the board itself is 5 volts. And I'm going to use this jumper cable to bridge that between the VI1 and 5 volts. Yeah, so should be able to see that LED, and let me just get that on there. Yeah. Now, there's definitely better ways to do that and safer ways to do it, but we have what we have. We have the tools we have. Yeah, so that's just constantly running. If it's over that, it sets it true. If it's not, it sets it to false. Next channel, disk relay here. So this is looking for a digital input. So in the background, the digital input, like I was saying earlier, it doesn't, well, it does work, but it's just definitely not a reliable way to use it. So what I did was just, I essentially do an analog read in the background, and I have a threshold value. Because it outputs 1.9, I said here, look, if it's over 1.6, it's high. That's just the way we did it in the end. And then that at least guarantees you that you have a known value that you can work with. And you can, you know, if you're up for opening up the library, you can change that value yourself. What I have this thing powered with here is 24 volts coming in on this. These things can take 24 volts. So I'm going to put 24 volts onto VI2, which you can see is this one here. So I'm just going to bridge using my trusty jumper cable. I'm going to put 24 volts here, and then on V2 I'm going to put the 24 volts, and we see the LED turning on. Nice. Yeah, great. You know, again, I didn't break anything. But you know, you should be careful that you don't if you're trying this at home. Channel 3 is this relay here, and I have it set up to turn on if the button is pressed. So I've got this button here, turn it on, turn it off. We just do that all day. And so the engine up here, it handles the debounce. The debounce is settable. It's in the button input example. You can see how to do that. Yeah, so on off with the button. What else we got here? RS485 communication. Right, so how are we going to do this? So what I have is check out my arm. This guy here. Again, another nice little AliExpress trinket. And this is RS485 to USB. What this section here is looking for channel 4. Or sorry, we're working with channel 4, which is this last one here. And what's happening is, if now these kind of pop-up things are annoying me, but if get data ready is true, and what's happening there is, in the engine, the communication side of things is, you know, constantly whirring around in the back. And then if you send a chain of characters over and you have the carriage return, what happens is it puts all them in a buffer, and it gets rid of the end character, and then you're just left with whatever characters were remaining. So if the communication engine finds the end character, it says, yes, we do have data ready, and then we can come in here, and then this function here will return the data that we received. So okay, let's set this up. So the RS485 to USB thing I showed you there, why is that not coming up? No, sorry, it's this one here. I did it from earlier. So it's just a serial port. It's on COM4. This is just something that I picked up here. You can put in anything here. You can put in Arduino Uno, or if I can spell, let's just put in Arduino. Perfect. But it doesn't really matter. because all we're doing is using the serial monitor here. So up over in the corner, we have our serial monitor, and maybe it does matter. Maybe we need to put in an actual board. Okay, but if I put in Uno, it'll work then. Arduino Uno. Select that. If I come up here to the serial port, yeah, okay, we get our serial port now. So from the top of it here, from the initialization, we're looking for a carriage return to signify that we have, received an actual message. And so we set our end character here, and we can either have it as, no end character, a new line, carriage return, or new line and carriage return. So all we're looking for is carriage return. And then our default baud is 115200, so we're going to set this to 115200. Now, so what this here is looking for is if the received characters is equal to this, so we're just going to copy and paste it in here and enter. That should turn on relay 4. And if we do off, copy, paste, and enter, turns it off. Now I'm just pressing up in the terminal here, and off, on. Exciting stuff, guys. This is good stuff. This is nice. Yeah, that's pretty much it. Okay, that's pretty much it. So yeah, so all this does here is this is a string compare. It checks what's in this, and it checks what's in here, and if there's no difference, it returns 0. So we're saying if there's no difference between these guys, it says 0, and we're saying here if it's equal to 0, then we do the thing. Right. Yeah, that's pretty much it. Like the board itself, it's got obviously the ESP32-C3, so it's got onboard Wi-Fi. You could do stuff with MQTT, you could do stuff with TCP Modbus over Wi-Fi. There's also Bluetooth stuff there you could do. But I just didn't want to go too deep into that stuff. I just wanted to give people a basic library to control the expansion board. And I have done that. You're welcome. Goodbye.